Black holes have fascinated scientists and science fiction lovers alike for decades. These cosmic behemoths are regions in space where gravity is so strong that nothing, not even light, can escape. They are born from the remnants of massive stars that collapse under their own gravity, forming a point of infinite density known as a singularity. But what would happen if you were to fall into one? Would you be crushed instantly? Or could there be a way to survive? Could black holes hold secrets about the nature of the universe hidden beyond their event horizon? In this journey, we'll explore the terrifying yet intriguing possibility of what it would be like to enter a black hole, the physics behind it, and whether survival is even remotely possible. Black holes are among the most mysterious and powerful objects in the universe. They form when a massive star reaches the end of its life and collapses under its own gravity. This collapse results in a region of space where the gravitational pull is so intense that nothing, not even light, can escape. Black holes come in different sizes, ranging from stellar mass black holes, which are a few times the mass of our Sun, to supermassive black holes, which contain millions or even billions of solar masses and sit at the centers of galaxies. The defining feature of a black hole is its event horizon, an invisible boundary that marks the point of no return. Once something crosses this threshold, it is destined to fall toward the singularity, the infinitely dense core at the heart of the black hole. But what happens when something or someone gets too close? Let's take a deeper look at the event horizon and what it means for anything that dares to approach. If you were to approach a black hole, the first thing you would encounter is the event horizon, a boundary that separates the black hole from the rest of the universe. This is often referred to as the point of no return, because once anything crosses this invisible threshold, it is permanently trapped by the black hole's immense gravitational pull. Not even light, the fastest thing in the universe, can escape. This is why black holes appear completely black. They absorb all light and radiation without emitting anything back. The event horizon isn't a solid surface, but rather a conceptual boundary. It behaves like a one-way door. You can enter, but you can never leave. The size of this boundary depends on the mass of the black hole. For a stellar mass black hole, the event horizon might only be a few kilometers across, while for a supermassive black hole, it could span billions of kilometers. Atam, if you were an observer watching an object fall toward a black hole, you would see something strange happen. As the object gets closer to the event horizon, it would appear to slow down, as if frozen in time. This effect is due to gravitational time dilation, a concept from Einstein's theory of relativity. The immense gravity of the black hole warps space-time so severely that time slows dramatically near the event horizon. From your perspective, the falling object would never seem to actually cross the horizon. It would just appear to stretch and fade away, its light becoming increasingly red-shifted until it disappears entirely. However, for the object falling into the black hole, the experience is vastly different. Instead of freezing in time, it would continue accelerating toward the singularity at the center of the black hole. There would be no visible sign of passing through the event horizon, no sudden shift, no barrier to cross. One moment you'd be outside, and the next you'd be inside with no way to return. But what would happen after crossing this deadly threshold? That's where things become even more bizarre and terrifying. Let's explore the gruesome process of spaghettification, the ultimate fate of anything that dares to fall into a black hole. The moment you cross the event horizon of a black hole, you are on a one-way trip to its center, the singularity. But your journey wouldn't be peaceful, far from it. As you fall deeper into the black hole, you would experience a gruesome and inescapable process known as spaghettification. Spaghettification occurs because of the extreme difference in gravitational pull between different parts of your body. Black holes generate tidal forces, the same kind of forces that cause ocean tides on Earth, but infinitely stronger. If you were falling feet first into a black hole, the gravity pulling on your feet would be significantly stronger than the gravity pulling on your head. The closer something is to the black hole, the stronger the gravitational pull. This difference in force would stretch your body violently, like pulling a rubber band to its breaking point. At the same time, the sides of your body would be compressed due to the way space is curved around the black hole. This means you would be both stretched vertically and squeezed horizontally, turning you into a long, thin strand, much like a piece of spaghetti, hence the name spaghettification. The intensity of spaghettification depends on the size of the black hole. If you were falling into a smaller black hole with a mass a few times that of our Sun, you wouldn't even make it to the event horizon before being torn apart. The tidal forces outside the event horizon are already so strong that they would rip you apart long before you ever crossed into the black hole itself. If you were falling into a supermassive black hole like the one at the center of our Milky Way, Sagittarius A*, your experience would be very different. Since these black holes are millions or billions of times more massive than our Sun, their event horizons are much larger, and the tidal forces near them are weaker. This means you could actually cross the event horizon unharmed, at least at first. You might even have a few moments to look around before gravity takes over and stretches you into oblivion as you approach the singularity. Your final moments would be surreal. Because of the way light bends in the intense gravity of the black hole, you might see warped images of the universe behind you, twisted around the black hole's edge. As time slows down from your perspective, you might even get a strange view of the entire history of the universe unfolding before your eyes due to extreme time dilation. Eventually, as you near the singularity, physics as we know it breaks down. No force in the universe can save you, and you are destined to become a part of the black hole itself. But what exactly happens inside the singularity? Does anything survive beyond this point? That's where science enters truly unknown territory. Once you pass the event horizon and succumb to the brutal process of spaghettification, you are on a one-way journey toward the singularity, the core of the black hole, where all its mass is concentrated. This is where things get truly bizarre because our current understanding of physics simply breaks down inside a singularity. A singularity is a point of infinite density and zero volume, a region where gravity becomes infinitely strong and space and time are stretched beyond recognition. According to Einstein's general theory of relativity, all matter that enters a black hole is crushed into this infinitely dense point. However, our physics can't properly describe what happens here because it merges two conflicting theories: general relativity, which explains gravity and large-scale structures in the universe, and quantum mechanics, which governs tiny particles and fundamental forces at the smallest scales. Since these two theories don't currently work together, scientists don't have a complete answer for what truly happens inside the singularity. It's one of the biggest mysteries in modern physics. If you somehow manage to survive the trip past the event horizon, you would eventually reach the singularity. But by this point, the tidal forces would have stretched and compressed you to an unrecognizable state. Your atoms themselves would be torn apart, as the fundamental forces holding them together would be overwhelmed by gravity. Essentially, you would cease to exist in any meaningful way. However, what happens next is purely theoretical. There are a few possibilities. 1. You become part of the black hole. The most widely accepted idea is that everything falling into the black hole simply adds to its mass. Your existence would end and you'd become a part of the singularity, forever lost to the outside universe. 2. Physics creates a new state of matter. Some scientists speculate that instead of infinite density, singularities might create exotic forms of matter that we don't yet understand. This could involve quantum effects that prevent complete collapse, though we have no way to test this idea. 3. A new universe forms. Some theories suggest that singularities might actually be the birthplaces of new universes. In this idea, when matter collapses into a black hole, it might explode into a new Big Bang on the other side, creating a separate universe. If this is true, black holes could be gateways to parallel realities, but we have no way to prove it. 4. You enter a wormhole, maybe. Some speculative theories propose that a singularity might act as a bridge to a wormhole, allowing travel to another part of space or even another universe. This is purely theoretical and has no scientific proof yet. Ultimately, no one truly knows what happens inside a black hole's singularity. Our best theories can predict what happens up until the moment you reach it. But beyond that, we are in the realm of the unknown. Until we develop a theory that unifies gravity and quantum mechanics, the singularity remains a mystery, a place where the laws of physics as we know them cease to function. But what if survival inside a black hole wasn't entirely impossible? Could there be any scenarios where you could make it out alive? Let's dive into some alternate theories of survival next. So far, we've explored the terrifying reality of falling into a black hole, being stretched into oblivion and crushed into an infinitely dense singularity. However, some theoretical ideas suggest that survival inside a black hole might not be entirely impossible. While none of these theories have been proven, they offer fascinating possibilities that push the boundaries of our understanding of the universe. If you were to fall into a stellar mass black hole, one a few times the mass of our Sun, you'd be torn apart by tidal forces long before reaching the singularity. But what about a supermassive black hole like Sagittarius A*, the one at the center of the Milky Way? In a supermassive black hole, the event horizon is much farther from the singularity and the tidal forces are much weaker. This means you wouldn't be stretched to death immediately. You could theoretically cross the event horizon and survive for a brief period, floating through the dark abyss. However, this wouldn't mean true survival. Eventually, you would still be pulled toward the singularity. The extra time you gain inside a supermassive black hole wouldn't help you escape. It would only delay the inevitable. Some physicists speculate that black holes might contain wormholes, theoretical passages that could link different parts of space or even different universes. The idea comes from Einstein-Rosen bridges, a concept in general relativity that describes how space-time could be folded in such a way that it creates a shortcut. If this were true, a black hole could act as a gateway to another location, possibly leading you out to a distant part of the universe or even a parallel dimension. However, current models suggest that wormholes, if they exist, would be extremely unstable and collapse almost instantly. Unless some unknown form of exotic matter exists to keep them open, using a black hole as a cosmic shortcut remains. Another wild but intriguing idea is that black holes might be connected to white holes, hypothetical objects that are the exact opposite of black holes. While black holes only pull matter in, white holes would only push matter out, never allowing anything to enter. If this idea holds, then falling into a black hole might not mean destruction, but rather ejection into another part of the universe through a white hole. Some scientists have even speculated that the Big Bang itself might have been a white hole explosion, possibly created from a black hole in another universe. However, there is no observational evidence that white holes exist. Quantum mechanics provides another strange possibility. Some theories suggest that information falling into a black hole isn't destroyed, but instead stored on its event horizon in a holographic form. This idea comes from the holographic principle, which suggests that our three-dimensional reality might actually be a projection from two-dimensional information. If this is true, then in some strange way falling into a black hole might not mean death, but instead you could continue to exist as a type of encoded data on the black hole's surface. While this isn't survival in a physical sense, it challenges our very concept of existence. Right now, none of these survival theories have been proven. Most of them rely on ideas that remain untested, and some contradict our current understanding of physics. Until we have a complete theory of quantum gravity, a theory that merges general relativity with quantum mechanics, we won't truly know if survival inside a black hole is even theoretically possible. But if any of these ideas turn out to be true, black holes might be more than just cosmic death traps. They could be gateways to something beyond our universe. Could they lead to parallel realities, new universes, or even a form of existence beyond our current understanding? In the next section, we'll take a closer look at the most mind-blowing possibility of all. What if you actually could survive inside a black hole? What would that look like? So far, we've explored the harsh realities of black holes: crushing gravity, spaghettification, and the inescapable pull toward the singularity. But what if, against all odds, you could survive inside a black hole? What would that experience be like? While this is purely hypothetical, let's imagine a scenario where the laws of physics allow you to exist beyond the event horizon. One of the most fascinating ideas is that the interior of a black hole might be much larger than it appears from the outside. Some physicists suggest that once you pass the event horizon, space and time could behave very differently, creating an entire universe within the black hole. Infinite space within. From an external perspective, a black hole looks like a compact, dense object. However, if you were inside, space might feel infinite, stretched by the black hole's intense warping of space-time. A new reality. If this idea is correct, you wouldn't necessarily fall straight into a singularity, but could instead enter a vast unknown realm governed by strange physics. This concept is partly inspired by solutions in general relativity that suggest black holes could be bridges to other parts of the cosmos. If black holes do contain hidden worlds, then perhaps falling into one wouldn't mean instant destruction. It could mean entering a completely new environment. One of the strangest effects of black holes is their ability to warp time. As you approach the event horizon, time slows relative to the outside universe due to gravitational time dilation. If you somehow survived inside, time might move much slower for you compared to the rest of the universe. To an outside observer, thousands or even millions of years might pass in what feels like minutes for you. In an extreme case, the entire universe could age and evolve while you remained relatively unchanged inside the black hole. Would this mean you're effectively trapped in a timeless void, or could you somehow use this strange effect to escape? If wormholes exist within black holes, then maybe, just maybe, you wouldn't be doomed to remain inside forever. Some theoretical models suggest that a black hole could act as a one-way tunnel to another place, possibly ejecting you into another part of the universe or even into a new reality. Some theories suggest that supermassive black holes could lead to new universes, meaning that if you survived, you might emerge into a completely different cosmos. Other ideas propose that black holes are actually wormholes connecting distant regions of space, potentially offering a bizarre form of intergalactic travel. However, all of these ideas remain highly speculative. Right now, there's no observational evidence that anyone or anything has ever escaped a black hole. If the holographic principle is correct, then falling into a black hole might not mean physical survival, but a different kind of existence. Instead of being crushed, the information that makes up you might be stored on the event horizon itself, preserved as data in a strange two-dimensional form. In a way, you might live on as an imprint on the black hole's surface, though in what form, if any, you could experience existence is unknown. This concept challenges our understanding of consciousness, reality, and the nature of information itself. Could your consciousness persist in some way, even after your body has been destroyed? At this point, survival inside a black hole remains a fascinating but unanswered question. Science tells us that falling into a black hole would almost certainly mean destruction, but theoretical physics continues to explore strange possibilities. Could black holes be gateways to new universes? Might they contain hidden dimensions where space and time behave differently? Could information, and perhaps even consciousness, persist inside a black hole in some form? For now, these remain hypothetical questions, but black holes continue to challenge our understanding of the universe. Until we develop a theory of quantum gravity, the true nature of black holes and what happens inside them will remain one of the greatest unsolved mysteries of science. Would you take the plunge to find out?